All right, hello everyone who may or may not actually be here yet. Just kind of wanted to take a moment here, well, to talk about done a lot of prototyping, but we haven't really talked about our drivetrain for Storm Surge much yet. Um, See if I've got the field info here. I guess this works. Um, yes, just what are people thinking about as far as the drivetrain to this point? Anybody have an idea for the drivetrain? Um, yeah, Coach Bargerman's here. Maybe one student, but oh. But anyway, so for those trickling in, let me get a new text thing up on screen. Of course, no idea why OBS defaults to things being off screen when you first type it in half the time. Let me make this a more readable color. Like blue? No, something that's easy to read. Red actually should. Make it like actually right size. There, let me make my screen bigger so things can actually be seen on my screen as I'm messing around with stuff. Anyway, so for those who weren't here yesterday, we talked a lot about grippers. Um, some of the sketches for that are in Slack. Some of them we just kind of saw on a robot from 2018, and I have a concept I'll show you all later that uses that gripper. I mainly did that just to show you guys how to like do like something resembling animation in Onshape. So I'm actually gonna do some organization in here while waiting for people to have A, show up, and B, have ideas. Big one. So and I'll put some ideas for things we need to consider in here just to get you all started. Yeah, cannot type this evening. But you all should have access to this fall 21 CAD robot folder. All the like design tool spreadsheets that we use for this stuff. Um, and such. These are all the subsystems that we really know about of at this point. The rest we need to come up with ideas for and prototype and see if they're even going on the robot. But I think we can be pretty confident that we're going to at least pick up and place rings and drive. So definitely need to start having ideas about that stuff. I'm just gonna write some like example goals for this. Do we rather want something different from West Coast Drivetrain? Let's establish our goals for the drivetrain and first, and then we'll see if we do. I mean, I'll be honest, I'm pretty sure we don't want to go away from West Coast Drive, but you know, there are some variations of West Coast Drive. There's 6 wheel, there's 8 wheel. You know, how many motors are we going to put per side? What gear ratio are we going to run? You know, stuff like that. We kind of need to get decided, and among other things. Execute. Because let me pull up the game info again. because wherever it's at, or that's the best picture of the field's in the supplemental info. Like this field has very tiny. I don't know. Actually, let, let me have you all analyze this. So what? How big do we think defense will be in this game? Like that is a huge question we need to answer early on. Is like how concerned should we be about this becoming just a defensive struggle of a game? Well, let me look. Let me pull up the field again. Well, so there are safe zones, but they're fairly small, and they kind of work like the trench and infinite recharge as opposed to the other ones, other safe zones and infinite recharge. So like you can be playing defense like parallel to these lines, like out here. Let me make sure that's even like really in here. Like you could be playing defense. There's some loading zones, safe zones. They're not really big. And there's a small safe zone around the goal, but like shooting a donut up at that angle seems actually more difficult than shooting it from like back here. That is a steep angle. So yeah, how big is defense in this game? Wide open floor. You actually have to like go around. If you're going from the feeder station, you actually have to go around your opposing team's like scoring point. Like if you're cycling from here to here, or even here to here, like they might just be like right there ready to go and defend you, even if they're playing offense. So personally, I think I know what I think of the defense, but I want to hear what the students think about how heavy will defense be in this game. No clue, honestly. Um, anyone but Graham have an opinion? Because he's stumped. I'm trying to think of a way to explain this maybe better. Because like there's going to be robots all over the field doing different things. Like you're on blue, you're either at the loading zone over here or over here, and your paths just end up like kind of naturally crossing quite often. Like I also kind of see the potential for a lot of accidental defense. It's like if you're down here and you're on blue and you're going from here and you can't go to this close one because your teammates there trying to score and you've got to go clear across. I mean, the path here that you take, red robot at the same time is going that way. Like it looks like defense will happen even when people aren't even trying to defend. And if you're trying to defend, like you can be very opportunistic about it. Like playing defense while you might be the only one here. Well, I guess when we're doing drivetrain analysis for next year, we've got Nathaniel, but hopefully people will file in as well. But so let's just cut to it. Defense is probably like big. Like it looks like it is like not only intentional defense, but just like the other team is just gonna happen to be in your way while they're trying to accomplish game tasks anyway. Um, so when you're designing a drivetrain, there are multiple ways to deal with defense. One is to try to push through them. I actually don't recommend that. Anytime you spend pushing on another robot is wasting time. Unless you are playing defense, in which case that's what you're trying to have happen. If you're trying to be an offensive robot, um, you should plan to be fast and nimble enough to go around the defense. Now, Swerve's really good for that. I'm just gonna say we don't have the resources to do Swerve, like period, at this moment. Nor will we in 2022. Like that's not gonna change in 3 months unless we get a lot of money and fast, and we have time to throw together a Swerve drive base before Christmas. But that's probably not happening. So West Coast Drive. It is very possible to make a West Coast Drive fast and nimble enough to like be very defense resistant. It just takes some forethought, planning, and probably a lot of motors, but and a good driver. It takes a lot of driver practice, but so does a swerve. So, oh, that was me sliding in my chair. Drivetrain will do X to get around defense. So probably need to be able to either, I don't know what X is. I'm not gonna put any like actual values. I might put templates for you all, but the students need to come into this document and like actually write down what our goals are because I'm not just gonna dictate to you our goals. Um, Also, once we kind of decide how, like what our ideal cycle distance is and like how we're gonna deal with defense, use the iLight drivetrain simulator to figure out the gear ratios we want. Based it off of like a West Coast products gearbox or a Vex Pro ball shifter or some common off the shelf gearbox that we have access to. But yeah, we really need to do that. Other things about the drivetrain. Um, do we? This isn't really a goal. Like, if we're going with kind of the like bumpers all the way around design and then just putting over the bumper stuff for grippers and such, that's we're not married to that design. It's just a suggestion. Um, you know, how do we want to deal with like, do we want to do a belly pan? Do we want a back pan like that 2910 robot? We have to start making decisions on that kind of stuff. The other thing is there's absolutely nothing on this field. Okay, let me go back to the field CAD. There's pretty much nothing on this field to drive over. And we had a heck of a problem in 2020 and 2021 with like accidentally driving over the game piece and getting stuck on them. Our bumpers, like just as a suggestion, our bumpers should be as low as legally possible, or as low as we can get them without having them drag on the floor. Because I don't want to drive over donuts. I think driving over donuts is a bad plan. Pushing donuts out of your way, fine. Bulldozing them, fine. Getting stuck on a bunch of donuts is a bad idea, or something that we should design to avoid. Also, FRC side bumper. There's a keep your bumpers low. Under you. R18. The robot must have a frame perimeter described in R18. Yeah. R18. So the floor and 7.5 inches above the floor. Um, so like if our bumpers are like half an inch off the floor, that's fine. Oh, two people in fewer than 5 minutes. It should be like two people in like a minute is what you really want for bumper installation. Just a note that that blue box there is a little optimistic about how much time we have between matches. Oh, virtually transposed. Yeah, yeah, yeah. Well, not relative to the height of the or 16. Yeah. Then how tall is a bumper? 6-inch. Yeah. Okay, plywood backing. Here we go. 2.5-inch pool noodles tall. So 5 inches tall. So if they're like, which will change something that I'm showing later. So if they're like a half inch off the ground and they go up to 5.5 inches, like that's fine. Because we'll just use them as let me open up the goals. I'm gonna put this as an or, and I will leave it up to the students. Like, if you guys think that the better move is to try to be able to drive over them, that is the student's decision. But we should probably pick one or the other because accidentally driving over donuts and getting high centered is a terrible plan. Especially if we can, can identify it this early. Yeah. If WCD 6 versus wheel. Bumper height. So I will leave this here for the students to deliberate over the. Honestly, I would like us to I would like for you students to have the drivetrain selection of what we're going to have figured out by next Wednesday. Would be good. I think may involve you guys coordinating and working over the weekend, but we're not going to have a meeting over the weekend, so you could use the time that we used to use for programmer meetings for that. Upper height. Yeah. So that's kind of what I wanted to say about drivetrain. I guess I'll leave it to Nathaniel to relay that to the other students and start pushing people into analyzing and making decisions. The other thing I want to highlight on that before we move on to other things is no. So you look here, zoom way in on it, and I might take chat off the screen so you guys can see this better. Is no whatever. You can see this is how the field's set up at the start of the match. And there's actually more graphics on this and everything. When you're looking at cycles and stuff, so it looks like on the field CAD that there are no donuts on the field at the start of the match except for one. Yeah, there's donuts all over the field, and we can pick those up in auto if we want. There's two under the triangle here. And then 1, 2, 3, 4, 5 on the center line. Those will be tricky to pick up, but potentially doable. So yeah, be thinking about auto strategy with that. If you're the cheesy poofs, what are you gonna do? Right. So onwards to doing some things in Onshape. So um, you can actually make assemblies of sketches. I think I shared a video about this earlier, but yeah, you can like I just made a part studio for like sketches. Like here are robot and bumpers for like a um 32-inch long frame, like side view. And the circle layer is just for a pivot for the arm. I'm actually gonna go edit this really quick because based on my ideas or my opinions on what the robot should be, my bumper should only be that high at the top. That also changes because yeah, it doesn't need to be 8. It's like 5.5. That only needs to be like. Oh wait, so I took was 7, so it's like 6.5 now. And then I just use assemblies. One thing about Onshape is like you have access to this ARM concept document. You can actually see the order that I did like mates and like what to. So if you're confused on how to do things, you can kind of go in here and see how I was doing them. Um, one thing I want to highlight, other than just showing that you can do stuff like this in Onshape, actually shortening that frame actually makes this whole thing work a little bit better. Huh. Is what was I gonna say? Oh, um, is that this Revolute mate works a little bit weird. It only allows rotation on the Z axis. Like so it has to rotate around Z if you can see that there. The blue one. I had to like my mate I spent like 20 minutes messing with this before I figured it out. I had to like do what's known as there's a button here for mate connector, and you can like click on an existing mate connector, like that little like thing. So like I can click on that and click on that and then do realign. I had to realign my mate connector so that it could rotate the right direction. Super annoying, but once you figure it out, it's not terrible. It's just like the first time you do it, it's like, why is there not just a checkbox here to select an axis? And I still don't know why there isn't just a checkbox there to select an axis, but if you're doing a Revolute mate, you have to make sure that your mate connectors are set up to where you will be rotating about the Z axis. The other thing here is that you can actually like set limits on your rotation once you get it right. So like I set this arm concept to where at like if I drag it this way, that's as far down as it goes. I can actually now so it gets down to where it's really close to the bumper and it's basically on the floor. I maybe need to make that like slightly. I mean, I need to go back into the arm drawing, make it like 8.5625 or something. Right now, 6.6125 is probably more what I want. if I go back to concept assembly, I hit refresh on the page, should be closer to the floor. Should be. But so yeah, it's where it can go down to the floor where it's basically resting against the bumper and rotate up as if it were going to go place a. I keep just calling it a donut. I think it's got like an actual game name. Or I was even playing around with being able to like take it to the other side of the robot to where maybe we could avoid driving back and forth. I don't know. I know I said not to worry about whole robot concepts, but I kind of wanted to just mess around with this for my own fun and enjoyment. So do not take this as a gospel thing of, oh, we have to design our robot this way. It's just a concept. Oh, data packet. Yes. So, uh, just an idea for a robot. Not, not the entire robot, just like an arm and intake combo mounted with a rotate point there on the frame. What may get more complicated with this is I think this roller and this like bottom pan may need to be able to like get out of the way as we're driving away from the post. So that could get weird. Oh, another thing is while I was doing this, I made a sketch of like this line represents the floor. That's the scoring peg like floating out in free space. So if you need this sketch for any concept that you're coming up with, I would not waste your time redrawing it unless you just want to learn Onshape more, in which case redraw it and then check it against mine. I also, this is assuming a 31.75-inch long robot, but like the max extension volume. So like you can see in that concept assembly that with this design, we're like well within our max extension and max robot height. Because I wanted to make sure that the dimensions all lined up somewhat close. And it's actually like surprisingly easy to like get an angle where I think like scoring on the post would be not terrible for the driver. But I will also say that like we were doing something like this, we'd have to have the robot done, like this part of the robot done like week 3, so that we could start getting driver practice. Because a game like Storm Surge is big on driver practice. Oh, and the curves on the top of this frame are just representing like the curve of the pool noodle. Oh yeah. There's also a side view of the data packet that you can use if you want to for your concepts. Yeah, that's what I wanted to go over there. A lot of people still aren't here, but whatever, we'll just continue. That's their problem. State machines. What is a state machine? What is an example of the state machine? Answer in Twitch chat. get rid of that question from earlier. What is a state machine? I mean, I'll even take copying and pasting Wikipedia. Like, not. Oh, I answered that before you even said that. Trying to not. Uh, okay. Well, a state machine is a piece of code or machine that changes its function based on a finite number of states it can be in. Such as, I mean, I'll give you the example that was actually for the lesson there, but recharge 1806. For example, if you want to look at a state machine code that you actually saw working in person, and actually one part of our robot that actually worked really well. I do say so myself. Is the hood. The hood has a bunch of states that it goes through based on either, user inputs, you know, goes to like position control and then it holds position once it gets there. There's a manual control state for being controlled by that. And so this hood, you can see this code here, is a state machine. But for the purposes of this lesson, there is a more friendly example. The Mario power-up states. That's also a state machine. The main thing I want people to get out of this lesson is that you can diagram a state machine. So like, there's 3 states. You can diagram like conditions that make it move to states. And this kind of diagram is handy for like beginner programmers understanding what they need, what needs to happen, but also communicating with non-programmers like a driver that isn't a programmer and like how a certain subsystem works. So, if it's doing something weird, like maybe it's ending up in the wrong state, which happens a lot on our robots when things are going wrong. And so that climber from last time, set one enable from disabled, we'll put it in the folded state, you know, set one unfold, or like the driver hit the unfold button and a second has passed, moves it to the unfolded state. You can fold it back up, which puts it back in the folded state. You can go back to unfolded. You can do set one disable and then re-enable it. You know, it's a state machine. There are 3 states. That's really all I had for this on programming. It was a exceedingly short programming meeting, but that's probably good because so there'll be less for people to catch up on. I was gonna just like take part of this lesson to play some Mario, but my capture card does not work on this laptop. So yeah. So yeah, for Wednesday, we need more concepts. We need to make decisions on the drivetrain, etc., etc. So I will get out of you all's way and get to it. Have a nice week.